today's notes will be on the law of conservation of matter, and we're also going to refer to as law of conservation of mass. So we're going to use these two forms interchangeably. So today started as the 16th. For some of you, it might be the 17th. So the law of conservation of matter or mass, so we're going to call it I'm going to abbreviate it, law of conservation of mass. And what it states is, it states that matter cannot be created or destroyed. So we had law of conservation of energy, which stated that energy can't be created or destroyed, it can only be transferred. So this is the law of conservation, states that matter cannot be created or destroyed. Okay, so let's see how this applies to what we're learning to right now. So we have been talking about chemical equations, chemical changes, and counting atoms. So let's look at our chemical equations. So the lab that we did last class, and even today, I think we finished watching it today. So let's look at, looking at my labs now, let's look at the first one that we did. So let's do the iron plus the copper sulfate, and we mix those two together, and it yielded, this yield sign means there was a chemical reaction took place, and this was a substitution. What happened? The Fe and the Cu, the copper and the iron, switched places. So this, what it yielded is we had a copper, that was little things floating around, plus iron sulfate. So here's a couple of things you need to know, that this over here, all of this right here, all of this on the left side of the chemical equation, these are my reactants. And on this side here, these are my products. And according to within accordance of the law of conservation of matter, these two things have to be equal. The reactants have to equal my products. So let's say, for example, let me just plug in some numbers. These aren't actual numbers, these are just numbers I'm going to plug in. Let's say that the mass, if I were to weigh this, and let's say that I had 5 grams of the iron, and let's say that I took 10 grams of the copper sulfate, overall my products would have to equal 15 grams. I don't know what they would have to actually be, we're not going to get into that, but I know that the total of my reactants have to equal the total of my products because of the law of conservation of mass. Now, another thing that we're going to be working on is balancing equations. The first step of balancing equations is to count my atoms. So if I've got, there's no coefficient here, there's no subscript, so the first thing I'm going to do is I'm going to list what I've got. So I've got an iron, I've got copper, I have sulfur, and I've got oxygen. I'm going to make that same list over here. So this is my product, my reactants, and here are my products. So here I've got iron, copper, sulfur, and oxygen. So if I go up here and I look, there's no subscript, there's no coefficient. I have 1 iron. I have 1 copper. I have 1 sulfur. I have 4 oxygens. Let me see what it says here. Here I've got no subscript, no coefficient. I have 1 copper, no subscript, no coefficient. I have 1, iron, Fe. Sulfur, no subscript, no coefficient. I have 1. Oxygen, I have 4. My reactants are equal to my products. Therefore, this is a balanced equation. And I know that the law of conservation of mass / matter is observed. Next class, we're going to get into how to balance it if they're not the same.